Okay, so we are going to be talking about factoring, which we've already said is one of the most important skills that you need to carry over from Algebra 1 to Algebra 2. So we're going to be reviewing what you learned in Algebra 1 about factoring. There are absolutely no new ways of factoring that we are learning today. So in this first station video, we are going to go through 2 of the 3 steps in the 3-step plan that should get us to factor any quadratic. So we're going to do step 1, and then we're going to do step 2. And then in the other stations video, we will talk about step 3. Okay, so first step in the factoring process, and this is kind of like an order of operations, meaning that you do, sorry, I need to find my color here. You do need to treat this as an order of operations, meaning you have to look for step 1 first. So first thing we always do is look for and take out a GCF, meaning do all the terms have a factor in common? It could be a number they're all divisible by, or it could be a variable that they all have in common. So when I look at example 1 here, 6x squared plus 12x minus 36. Hopefully when you look at those 3 terms, it pops out immediately to you that all 3 of those terms are divisible by 6, which means that that is our GCF. So GCF in this case is 6. Now, once you've found the GCF, the actual factoring part is to take that GCF and put it out in front. This is like reverse distributing. And now what we're doing is we're dividing each individual term by its GCF. So 6x squared divided by 6 would be x squared. 12x divided by 6 would be 2x. Negative 36 divided by 6 would be negative 6. And so then we would have our GCF factored quadratic here. Now, of course, there are going to be other steps afterwards that we would look for, but this is always our first step. Identify and then take out the GCF as needed. So every single problem that is on your homework worksheet, this needs to be what you do first. All of them need to be checked to see if there is a GCF. If there is, you must take it out first. All right, so let's look at example 2 now. So look at each of these terms. Think about whether they have a number that they're all divisible by. Think about whether they all have a variable in common. In this case, they're all even numbers, which means they have to all be divisible by 2. And they all have at least an x to the first power. So that means that in this case, our GCF is 2x. So we put the 2x out in front. 4 divided by 2 is 2. X cubed divided by x is x squared. Next term, 6 divided by 2 is 3. X squared divided by x is x. And then final term, negative 8 divided by 2 is negative 4. X divided by x is 1, so we don't need to put anything else there. Remember, like I said a minute ago, if you were to redistribute your GCF, you should get back your original, because multiplying out is the opposite of factoring things, because factoring is a type of division. So if you were to multiply it all back out here by distributing, you should get back your original. If you don't, then you have not factored it correctly. All right, so that's step 1, GCF. Always do that first. Next are our special products. This chart you need to study. Again, none of this is new. You did both of these types of special products in Algebra 1, but it is imperative that when you look at a factoring problem, that if it is a difference of squares or a perfect square trinomial, which we call a PST, that you are available and able to identify it quickly. So difference of squares take the form a squared minus b squared, which I've made kind of a little checklist here. So the first thing, if it's a difference of squares, it has to be a binomial. Remember, binomial means it has two terms. So in this case, we have a squared is one term, b squared is the other term. So is it a binomial? Separated by subtraction. Has to be subtraction. If it's not, then it's not a difference of squares. If both of those things are true, it's a binomial, it's separated by subtraction, then you have to see if both terms have perfect square roots. If they do, then here is how you factor a difference of squares every time. Look at the two parentheses. You take the square root of the first term and you put it in the front on both of them. Then you take the square root of the second term and you put it in the back on both of the parentheses. The only difference between the two parentheses is that one of them gets a plus and one of them gets a minus. The order is not important. So, meaning if I were to factor this example, the square root of a squared is a. So a would go in the front of both parentheses. The square root of b squared is b, so that would go in the back. One of them gets a plus and one of them gets a minus. PSTs, perfect square trinomials. Here's your checklist for that. First and third terms both have to be positive, and it has to be a trinomial, meaning that it has three terms. So here I look, three terms, first and third are both positive, both pluses. So check to that. Then do the first and third terms both have perfect square roots? Square root of a squared is a, square root of b squared is b, so yes. Then here's the one that people forget to check. Those square roots that you just took, so I said the square root of a squared is a, the square root of b squared is b. That middle term, if you take those square roots and multiply them, so ab, that would be this part. If you double it, it should be the middle term. So AB, when I double it, is 2AB. So yes, this fits. So check, check, check to 1, 2, and 3. That means here is how a PST factors. PSTs are really, really important because we actually also use them when we complete the square, which is another way to solve quadratics. So in this case, if this had been a plus, the format would be the square root of the front goes in the front. The sign of the middle goes in the middle. So if this were a plus 2ab, it'd be a plus here. If it were a minus, it'd be a minus. The square root of the third term, so b squared, which is b, goes in the back. And then you put a squared on it. So a squared plus 2ab plus b squared would be a plus b squared. If it were a minus, it'd be a minus b squared. Okay. So we're looking at example 3 and example 4 now, and we're just looking at them to check. Now remember, first things first. Once we've learned step 2, you still have to do step 1 first. So first thing I do is I look for a GCF, which in this case, even though there's a GCF between the last two, the first term is not divisible by that. So there is no GCF here. So next, I look to see if it could be a difference of squares. I very quickly know that it's not because it has 3 terms, not 2. It's not a binomial. So then I look to see if it could be a PST. So is it a trinomial? Yes, 3 terms. Are the first and third both positive? Positive x squared, positive 49. Yes. Do the first and third terms have perfect square roots? Well, square root of x squared is x. Square root of 49 is 7. So yes. Middle term, 2 times those square roots. So in this case, it'd be 2 times x times 7, which is 14x. That is what's in the middle. So yes, this is a PST. Yay. So use my format. Square root of the front goes in the front. Sign of the middle, which is a minus, goes in the middle. Square root of the back goes in the back. And I put a squared on. Like I said in step 1, you should be able to multiply this back out to see if it gives you the same thing. If you were to FOIL this, you should get back your original. If you don't, you didn't factor it correctly. So you can always check your answers. Example 4. Step 1 is always the GCF. So I look, these are both even numbers, which means they have to have a GCF of at least 2. So I take the 2 out in front, so that's my GCF. 2x squared divided by 2 is x squared. Negative 392 divided by 2 is negative 196. So now that I've taken out a GCF, now I check what's left. So I already did GCF, so now I look for difference of squares. Is it a binomial? Yes. Is it separated by subtraction? Yes. Do both terms have perfect square roots? Square root of x squared is x. The square root of 196 is 14. So yes, so that means this is a difference of squares. So that means the x squared minus 196 is going to factor further. Don't forget to bring down the 2 that was already there. So now, difference of squares, square root of the front goes in both the fronts. So that's x. Square root of the back goes in both the backs. So 14. One of them gets a plus, one of them gets a minus, and then this guy is my final answer. All right, so that reviews 2 of the 3 steps to factoring. So make sure that you check for them in that order on your homework.